Okay, so before the class, or before the break, we were introducing vectors. I'll start erasing the board here. And it's when the value that we care about is made up of multiple numbers. That's what a vector is. Those numbers go together. And generally, we'll think of them like an arrow. And I believe I mentioned it earlier. There were some comments on the break about teaching trig, and I made a comment about it's still taught the old school way, even though better ways to teach it are known. Another comment came in about calculus, and that's the same way. It's taught with that old school rigor. We could picture a German high school in the 1850s teaching their students, right? A super rigorous militaristic approach to it, which does not work for most people. Calculus is another one that it should be a very natural process for how we live our lives, but it doesn't come out that way. But just some basic stuff about vectors, that'll get us through. That's a whole nother discussion. I could go on the long rant now. But the basic idea of vectors should get us through game development. Treat each component separately and think of it like an arrow. So that arrow, we consider the overall arrow in terms of its horizontal and vertical components, because then it can move around. And I think I mentioned it already. You might have saw it on the thing. There is a math quiz. One of our quizzes will be a math thing, and study of the math we need is a combination of a bunch of high level stuff. So I couldn't find a good resource for that. So this is the first 2 questions or so on the math quiz. It'll be something like this. I'll give you a vector. I'll give you something like that. Maybe 2, 5 plus 4 times -1, 3, and ask you to do that math. So that'll be one of the quiz. That'll be one of the questions when we get to that. And when I do that, I will set it up so that you can do a file upload, so you can take a picture. Just do it on notebook paper and do it upload, and then I'll just want you to draw it out. Like obviously write the answer down to confirm it, but maybe draw those out. So -2, 5 is over here and up here somewhere. And we're going to add that to -1, 3. Which is 1 like here somewhere, but we want that one 4 times, so that's going to be 4 times as long. So when we add that, move that vector up here, it looks something like that. So I'll just ask you to set it so you can do a file upload, and then that'll be one of the quiz questions, maybe 2 of them, and you just jot it down on notebook paper and upload the picture. If we did this 2 plus -2 plus -4 is -6, and 5 plus 12 is 17. So that's where our end result should be, 6 over and 17 up. So that'll be the first of the math questions on the quiz, something like that. Just let you know it's coming. Maybe one other one in the simple. That'll be the harder vector question, and then there'll probably be an easier vector question about the concepts we just talked about as well. But that quiz is it's obviously not ready yet. We've only seen the first question on it, so it'll be 10 questions long like our other quizzes, or it'll be 10 points. Probably won't be 10 questions. But that's what will be in. That's what the quiz question will be like, and then it'll be set for a file upload, so you can sketch a quick image or even draw it on paper and take a picture of it for that question. So hopefully that also gives you an indication that when we get to that math quiz, it's not going to be bad, because it's all going to come straight from the video lectures, and I will explicitly point it out like that. But okay, this is something that's going to be on our math quiz once we have 10 points worth of math that we've covered. Okay, so a couple other things to look at. I guess one thing I wanted to mention is just kind of a little note. So I'm going to share my screen and point at a word that's in our assignment this week. And just use that as a stepping off point for a little point that I wanted to make that didn't really fit in with other stuff very well. So our Module 3 programming assignment was pointed out to me right beforehand that it's off. I used the physical textbook when I was putting the page numbers on those instructions together, and I forgot that Pearson relabels their page numbers for their ebooks, and the ebooks have much bigger pages. So it's page 459 in the paper version, but it's I think 195 in the ebook. So I'm going to change the instructions to go with the chapters. The chapter names are still the same, but we're going to follow this prototype chapter, which is very straightforward. And prototype is a model, right? That's usually not the final version. It's a step along the way, like we design a new component for engineering, stepping into that simulation version. We want to make sure it works before we spend a fortune making it. So we make a virtual prototype of it, a virtual model, and then do some testing there. So our first one is this prototype 1. It's chapter 28 in both paper and the thing, but the page and ebook, but the pages are different. So they talk about prototypes, kind of, you can see it's stepping through. They give that, looks like they're writing their vectors as horizontal matrices. So we still have the square brackets like a matrix, but it's going horizontally instead of vertically. Because that's a lot easier to type. We have to use LaTeX and actually set it. So you see a bunch of pictures, and then somewhere in here, there's some code to follow along with. In my class, more is always acceptable. Flow charts to cover the lecture. Oh, and then we get down to some C# code to follow along with. And if you want to improve it and add your own little flares in there, that I'm perfectly okay with that. The assignment as it's given is the baseline. If you want to do more, because more is going to mean more practice and let's get better at what we're doing here, that's always acceptable in my class. So if you want to break away from this and try your own thing and maybe challenge yourself a little, because it's through challenging ourselves that we improve at things, feel free to do so. But the thing I was going to look at is the prototype. The word prototype itself, we're making a model. Is there a long version at the end? Is that summed up somewhere? It looks like it's still broken up, but by the time we get down to the end, we're going to have a whole bunch of code we've written. It's going to be a big, long, quite a bit of code spread out amongst several scripts, along with our graphics, and there's a lot going on. And in games, all that stuff that's going on is intermingled, right? It all goes together. So as we'll start from scratch and then add pieces and add pieces and add pieces, and it's going to get bigger and bigger and bigger and more intermingled. So something to keep in mind, probably won't need it the first week, but keep in mind that it is okay to go make a smaller prototype for your prototype. And if you get near the end and there's a lot going on and you have to add a new feature in, so a lot of times, especially in things that aren't under time constraints of a classroom, when we're making a big game for release, some big, huge, complicated mess of code and graphics that are all tied together, and we want to add a new feature in there, debugging that in place adds some extra difficulties. So it is okay to go make a smaller prototype, right? Go start a scratch game that only has that new feature and maybe just a couple things, so it's really small, just a couple things so it can interact with other stuff, and get the debugging done in that prototype where you only focus on that feature. And then once it works, then move it into the big, complicated, intertwined thing that is your actual game. So keep in mind that that's okay with that word prototype. You can think of it as sub prototypes. As the games get more and more complicated, when you're prototyping things, stepping away and making a smaller prototype for just the new feature can make it a lot easier to debug that feature. So then when you bring it into the game, the only debugging that's left is the interaction with other pieces. You know, the thing works on its own. You know, the rest of the game works without it. So all you have to worry about is putting that puzzle piece into place. You don't have to worry about all of it at one time. So that can be, that was something that didn't really fit in any lectures I wanted to say somewhere. So seemed like a good place to mention it tonight. So we haven't looked at all the tools we're going to use this semester though. So I wanted to at least take a quick preview look at the 2D software we're going to use and talk for a little bit about file formats. Oops. That's why.
No,
I already got my regular mouse and it was sitting crooked and kept doing weird things to me. Yes.
It is okay that we use a different 2D software, correct?
Yes.
Okay.
Yes. The 2D, that was just the one I was using. So feel free to use whichever one you're comfortable with. If you already know one, use it. And yeah, I was going to show you what I liked about this one, which what I really wanted to talk about while we're in preview mode is the file formats. So I'm going to use one called Inkscape. This is an open source one. It's actually written in C++, but it takes plugins in Blender. It has a C wrapper, not Blender. Sorry, it takes plugins written in Python. It has a C wrapper built in. That's, if you haven't encountered that before, that's where we write our code in Python. And then we run it through a C wrapper, and the C wrapper essentially parses through our Python code and turns it into C++ code. So then we get the advantage of writing our code in Python, but the speed of running it in our fastest language. It's a very, very common thing. So here's this one I chose. It's called Inkscape. There's lots of different ones. If you want to use Microsoft Paint, that's fine. What was that one you had, Tyler? I'd heard of it before. Yes, the question popped up of translators for programming languages. Yeah. When you get to your mobile app development course here, if you're taking the SDEV program, you're probably going to take it as far as Android apps. Bloomington out of Bloomington, they usually run one class using Swift to do iOS apps, but Google actually wants our Android stuff written in a language called Kotlin, which is a strictly typed object-oriented language. Java, C#, C++. There are lots of strictly typed object-oriented languages more popular than Kotlin. So in our IDE that we would normally use for that, Android Studio, there is a button that we write our code in one of the more popular languages, Java, C++, C#, or one of our other more popular languages, and then we click that button and it turns to Kotlin, which also happens when we compile, because Google wants us to use Kotlin, but way more people know Java. So typically that class is taught in Java, and then when we hit compile, it gets translated into Kotlin and written down. But for the question in the chat room, they're translators for programming languages. Yes, because a programming language is a text file. We're writing a text file. And actually, yeah, you have that homework due this week. due tomorrow. You have to parse through a text file and make sense of that, of a text file. It's not a programming language there, but for our class tomorrow night, you have to parse through a text file and read it. So when we put code into a text file, we can parse through that text file, read the words that are there, look for, say, the Python keywords like DEF to define a function. And when we find that in the text file, we can say, okay, replace that with function, to like we would use in JavaScript as our keyword for doing the same thing in JavaScript. And when we see those in Python, we see that see the colon followed by a bunch of stuff indented. Whereas we're parsing through our text file, we can say, okay, replace that with some curly braces. And then we've switched a Python function to a JavaScript function. Oh yeah, and then every time you see a line feed, add in a semicolon. And by parsing through a text file, we turn Python into JavaScript. We can do that for any language because it's just a text file. And when you're studying a programming language, that's something you're going to have to do, is parse through a text file. That's a standard assignment. Yours is due, you have one due tomorrow, Mark, of parsing through a text file. So if there's code in that text file, and again, with the more is always acceptable, if you want to do that for your assignment tomorrow and turn some Python stuff into JavaScript or another language that you already know, that would be a great practice for that stuff. Turn it into C# because that's probably fresh on your mind. I would be fine with that. Okay. But that's essentially just parsing the text file. When we see a keyword, we replace it with a different keyword. Special symbols, we replace with a different special symbol. Very popular to do it between Python and C++, because then we get the ease of the easiest language to type our code in and the speed of our fastest running language. There are a lot of things that C++ is even faster than assembly language, which is very interesting, because assembly language should be closer to the machine. But when we put timers on them, C++ ends up being faster on a whole lot of things. But it's kind of hard to write C++. So if we could just have the computer write C++, that works out a lot better. So yes, so Inkscape is open source, written in C++, but it accepts Python plugins because it has a C wrapper. So it will turn any code we write to automate our image from Python into C++, so it will work that way. So that makes me think this goes nicely with Blender, because we do our scripting in the same language. The big thing though is when I go to save something, we'll see when we save it. That's the main reason I wanted to use this one. So zooming in and out, kind of the same. Control click or control scroll, or control plus and minus, or plus and minus do our zooming. I think everybody's probably familiar with that. Control plus, plus and minus, we don't have to have control. I'm used to that elsewhere. Plus and minus, or hold control and use your scroll wheel. So here's our drawing surface. You might want to set it up. So if you go over file, there's document properties. We're doing everything in pixels, so make sure you set your unit. You probably want to set your units to pixels, and it has to be set twice. So here's the one on the labels, and here's the units for actually working with. So anytime you change your units, you want to change both of those. Set the transparency, background colors, all that. That's under file and document properties. So a lot of stuff like that, and you can save that as a template, which is kind of how I got here. And then we have normal stuff like we would see in 3D software. We can draw a box or a circle, adds a different color to that, some other shape. I guess a star shape, blue, and That we could do in Microsoft Paint with no problem, about the same 3 clicks. The difference here, so notice I can still select each one. I can come back here and move this around. Or I can decide, okay, maybe that should be lower. So I can right click on it and it's not that move, there's a different move. Maybe I have to come up here and lower that. So put it behind the other shapes and move them around, they're still separate. And when I go hit save, oh, I did find something I did yesterday that I did not like about Windows 11. If y'all haven't encountered it yet, these 3 folders, my music, my pictures, my videos, we cannot delete them, and our scripts do not have access to work in them. I just learned about that yesterday. So what I did in yesterday's class is I put a try catch block, and the catch part just said pass. So just ignore if we hit one of those files while we're working in our folders. But in Windows 11, we cannot delete those 3, and a script, an automated process, does not have access to do anything in those folders. So it throws errors if you try. I just learned that yesterday. So if I come up with a solution, I will make sure all of my classes know about that. But that's the first thing I've encountered that I just really don't like about Windows 11. Because that causes errors if we try to have a script like search through for a particular folder or something. Just thought I would share that with you because at some point I might do that. I'll just call this test 1, 2, 3, any picture name, but notice our type. It's a SVG file, Scalable Vector Graphics. And Microsoft Paint or a lot of our other ones, once we draw that stuff, it's set. We can't come back and access just that circle all by itself, or just the square, because they're set up as ping or raster graphics is the overall term. I wanted to talk about pings and JPEGs somewhere. JPEGs are a cosine, a Fourier transform on a cosine wave representing color data, and pings are layers of color. So each color gets its own layer with holes in it and stuff. And I wanted to talk about those at some point, but scalable vector graphics, if I go in here, if you haven't seen them before, that is a text-based thing. You may have seen it with HTML in conjunction with HTML, a markup language that carries our image data. So an SVG tag with a bunch of attributes in it, the width and height attribute and some other details. And then tags to mark stuff. So there's like a rectangle tag. It has a position, width and a height, an ID so we can refer to it in code, the colors, and all that stuff is there. A path, I think this is referring to to the star shape. So a bunch of lines, we have a bunch of different points. Oh wait, I see C's and R's, so that's our circle, the center of the circle and the radius of the circle, all that information. And it's stored here as vector graphics, which is a lot like the 3D stuff we were doing. This is the standard for, kind of the standard for 2D graphics. We do them as scalable vector graphics, which makes a nice organized format, easy to work with in our scripts, highly automated process to write them. So that's how a lot of our 2D stuff is going to work with, and everything is still handled independently. So there's those shapes. I'm going to delete those because when we're drawing, we probably want something a little bit better. And that's where things like this come in. So we can do Bayesian curves. If you encountered those, perhaps for timing functions. Notice when I add a new point, it changes the stuff that was already there. So that's a Bayesian curve. We can set those up. Or just a linear curve. This is the one you probably want to start with, where we can just draw a bunch of points in space. I'll start there, come over, down, something like this. And when it closes back around, then we have a whole shape and we can add in some fill colors or something, change different options on it. We go to object, fill and stroke. We have absolute control over it. And when we save that, whoops, yeah, oh yeah, save. If I come back, oh, it's still open. Oh, it's not still open. And save it, it closes that. So when I come back over here and open it with the text editor, we usually see something like this when we draw it that way. So we just have this path. And as you look through here, we have a two-dimensional point. I should probably turn on word wrap for this. So we have a two-dimensional point. Then we have another two-dimensional point. And another point. And another point. And the M here at the beginning means we're going to connect all our points with straight lines. So you might have seen that in math class, y equals mx plus b. So just a straight slope to connect these points. And then it's a lot like we were seeing in the 3D stuff, right? We have a bunch of points in space, and then the computer will connect them. So that when it's time to animate it, well, we can have a program or a script modify these points in space and create that animation. And we don't have to do frame by frame. So animations are using scalable vector graphics for animations. Well, really, vector graphics for animations means we don't have to draw every single one. We can just have the computer recalculate a change in these points, and then we end up with an animated process. So that's probably a good start, is to set up some like hard points in space. So very quickly here, just kind of clicking around some dots, that'll work. Oh, I guess I didn't close that. Close that, turns into a shape, and then we can give it a color. Come down here, do some other ones. And close that up. And quickly draw a character. It's vector graphics, so we still have access. We can grab any particular one and move that around in space. Seems to be snapping. Snap seems to be on, so it's trying to jump to certain spots. If snap's getting in your way, that's the buttons over here on the right. These are different ways we can snap things. Then we get free movement of where to put it. And we have the different pieces to make up a character. So when we go to animate that, even if you have like some sort of raster graphics where you're doing pixel by pixel data, you're probably going to you'll want to do it in multiple pieces, separate it up into multiple pieces so you can automate the animation process. It'll make a big difference. So that was this tool right here. We just click a bunch of spots and really just making a polygon. We click a bunch of corners and it connects them. We have another one we can use, which let's see, I'll kind of delete this stuff. Whoops. I'll delete those shapes and we can get back to any of them. It gives us some editing capabilities. Things are still kept in layers. Right below that pencil I clicked on that gave the Bayesian curve, we just have a regular looking pencil. And this is one we can just draw with all together. So I'll do a quick picture here. So I'll like draw a blue box and then maybe another box down here. Make that green. And then we could grab this pencil and draw freely like a pencil and get all those vector points in space. So like a tree here. I'll draw all around there. And when it connects back, once again, we have a single shape that we can fill in with a color and do all that. I'll come around and draw another one. That'll work. Fill that in with green as well. And again, everything's still in layers, so it gives us a bunch of drawing tools like we're probably used to. The biggest thing I wanted to talk about was those scalable vector graphics though, because it remembers it as a bunch of separate points in space. We can rotate that if we need to, move it. We have lots of control over it. And kind of get things worked out the way we want them to. A lot more control, and we can automate it easier. So if I go ahead and save it, the main thing there, you can click here and look around on buttons. We'll see that a little more detail when we're ready to do animations. But the main thing I wanted to talk about there was the scalable vector graphics, the SVG graphics. Oh, cool. Adam did update. So scalable vector graphics, 2D stuff, we typically save in a markup language. It's a good form, works great for computers, not too bad for humans. So it's a good intermediate style to work with. And we have those vectors in space that we can connect. So you see now the path has a whole lot more points in space that are connected. So we can let the computer keep track of all that, and then we can animate that, like say the tree waving in the wind, simply by having the computer adjust these points appropriately. You can see there's quite a bit of them. So that's scalable vector graphics. I'll keep that open to compare it to the other format. That's pretty much the standard for 2D vector graphics. How we store the thing, obviously internal in binary format, it's a little bit different to the machine. This is the human readable version. But 3D gets a little complicated. So also wanted to, for a comparison, I wanted to go ahead and open Blender and look at our standard format for that. So I'm just going to draw something really quick in Blender. Hopefully this won't take too long. So besides the other day, I'm going to hit W to get to the selection tool I like, the freeform selection, delete all this stuff, and then add in a new cube. Which when we add stuff, make sure you're in object mode, because if you add in edit mode, it will treat it as part of the same object. Let's see. So here's X and Y. So I'm going to scale that along the Y axis and make that a little longer. That'll work. Go in edit mode. Right click. Let's subdivide that. That'll work. And maybe if I hit Control R, whoops. Yeah, I'll put a ring there. Control R, put another ring down there. Oh. Down there, that'll probably work. I can get rid of some of these points. So maybe get rid of that point. That point. That point. And then make a new face that just goes from here over to here. Close that up with a new face, and same thing over here. Select those points, close it up as a face. Down here, and that'll work. You can make little adjustments to it, like select those, move them further out. Select those 2 points and move them in and up and something like that. The most recent assignment was a canoe, but that's how you would, what I was wanting you to do for the assignment that I think was due today. Make a simple canoe, just keep adding vertexes and taking them away. Can add a knife in here and maybe cut out a little shape. Hopefully. Let me start here, where it's not clicked into anything. So now if I select a few of these through here, have those faces, bring that down so it's sunken in like a canoe, and just move those vertexes around until you get the shape you want. That was the assignment. We don't need to spend a lot of time over tonight. That's a basic shape that'll work for us. I'll go ahead and save this arbitrarily. I'm still in the delete folder. Yeah, that's Untitled is fine. I start on that canoe shape, but the main thing I wanted to look at is our format for doing this. The standard format can kind of be seen most clearly. We use it in different places. This is how it looks in a programming language. A lot of these do this in the background, but it can be seen most clearly in a wavefront, which is .obj. So if you're using something, if you're using Blender, send me the Blender files. But if you're using something else, please export it as a wavefront or a .obj file. Sure, I'll call it that. I don't need a name on this. I just wanted to look at how the data is in there. Don't need to care about what it's called. This sort of epitomizes our standard format. Did I not just export that? Export the wavefront. There it is. So that gave the .obj file, which Windows should know what to do with. By default, that should open up in the 3D viewer that comes on Windows. So I don't know why it doesn't recognize that, but so we have two things. So we have a file, the OBJ and the MTL. So our mesh itself and the material. So I'll open both of those with Atom, which is probably quicker if I just go over to Atom and open it. Can I open both of them at the same time? Yep. Okay, so here's the object file, the .obj. And this is how it's stored, as a little bit of some header information. And then we have, starting here on line 5. So line 5 is actually line 1. Please keep that in mind as when we get down later. Line 5 is number 1, or since we probably want to think about this in terms of program, well, it's going to say 1. So line 5 is line 1. When we do this in, obviously when we do this in code, our first vertex is going to be number 0. So it's slightly different than this, but this format starts at 1. So here's a vertex in space, -1, X, Y, Z coordinates in space. -1, -0.63, 2.4. Then we have another vertex in space and another vertex in space, and all the points. So as you scroll down, that little shape I just randomly threw together there has a lot of points. And then VN, this is Vertex Normal. This is outward and inward. So this is an arrow. So anytime we have a polygon, right, we connect a bunch of vertexes and those form together into a face. So we have that, but we're making a 3D model. So we also need a normal vector, which is the outward direction. Because when we put that in our shape, there's going to be a difference between the outside of it and the inside of it. So that's the second piece of data here. Is obviously 3D stuff would look very, very complicated in a markup language. It organizes 2D vectors really nicely, but 3D stuff becomes a mess. So we have long list of points. We start on line 5, goes up to 56. So it looks like there's 51 vertexes there. And they form a bunch of polygons. So then we have vectors saying which direction is outward. VT we can ignore for now. That's some transform data. And then we get down here, F for face. So way up here, we had V for vertex, and that's all our points in space. And then way down here, we have F for face. And notice this first one, 42, 59, 1. 35, 51. 491, 12, 21, 1. So it looks like a few different things. Are those all triangles? Yeah, I guess they are. So what those numbers are, so there's what this is saying is there's a face, and we have one corner of it is vertex 1, vertex 21, and vertex 12. So if we scroll up to our way up top to our list, go back to the home. So here's vertex 1. So this vertex connected to 12, which would be 17 on the list. So here's our number 12. I think, is it 18? Oh yeah, 17. So those two vertexes, along with 21, form a polygon. Oh, I'm thinking backwards. It's these corners. So vertex 42, vertex 35. Sorry, I was thinking of how I do this in Python. It comes in backwards in Python. But generally vertex 42, 35, 4, and 12. But as programmers, we can think of those as indices on the list. So those 4 corners, those represent 4 vertexes. So we could go up here and find those in the list, the ones with that number. And then along with that, we have 2 other pieces of information. This middle piece, our wavefront files go right in order. So that middle piece is our normal vector. So that says what is outward, that point, that's an arrow pointing outward from that particular corner. And then I guess, vertex transform, the linear information on it, the angle we're looking at it, is the first one here. So from the angle we're looking at it, we need to apply this like scaling. Because when we look at 3-dimensional objects from an angle, things change. So we have a long list of vertexes, then an arrow saying some information saying which direction is outward, and then some scaling stuff. The angle we apply at, basically the angle it sits in with respect to other stuff around it. And then like here we have, that gives us 4 corners, and then those 4 corners make a face. So different 4 corners here and different 4 corners here, but we have 3 pieces of information about each corner. Or this looks like a much more complicated polygon. It's got a whole bunch of corners. There's a whole bunch of sixes there, so it looks like it's pretty flat, whatever it is, as far as its own thing goes, but there's a lot of quarters. That's our standard format for 3D data. So this is kind of what we have to work with. Sometimes we'll need our script to do that. And when we drag our mouse around in Blender, the computer is producing this data for us. So really, this is the data we have to work with. And for 3D objects, we also have materials. So it's essentially this format, however we're working with it. So like in Python, it'll be a long list of vertices and then a long list of faces that refer back to all those vertexes. So we'll have a face that, and then the face will say like vertex, what is that? 3, 11, 28. We'd have those 3 indexes in our face list, and then those refer to 3 of the vertexes in our vertex list. So we split it up and store the data that way for 3D. We also have materials, which there's none here, but this gives the information about materials. I want to come back and look at that whenever we get there. So this is one of the most common standards, the object wavefront, which has object.obj and .mtl. And we can't really tell it here, but when we get to the material, it was written by a German. So the abbreviations don't match like we're used to in America. So many things that get abbreviated were abbreviated from English. So when we see the abbreviations in the .mtl file, they're abbreviations from German, which is English is based off German. So it's not that different, but they are a little different. We'll come back and look at that. But that's the sort of data we have to work with once we draw our images. We saw Blender files, so we have a whole bunch of vertexes, and then we have a list saying how those vertexes go together to form faces or edges. Usually one implies the other. Faces are more common, but if we kept a list of vertexes and edges, we have that face data. Just like when we have the faces, we automatically have the edge data because that's the thing surrounding the face. And our SVG graphics, as far as vector graphics, the most common form is going to be to use a markup language. So these 2 pieces of software give us this, and then you'll see essentially we have the same data, right? We have points in space, and our M means that we're connecting those with a straight line. So we'll connect those XY coordinates to these XY coordinates and so on and so forth, and these XY coordinates and these XY coordinates. And we have that long list of vectors that get connected into a single path, which if it fully encloses, the computer can fill that in and call that a face. So it really is just 2 dimensions of what we're doing in the 3-dimensional stuff. We set up our vector. It's just our third component is always 0 for the 2D graphics. We just drop that third component and combine a long list of vertexes into the face we want. So that's the 2 pieces of software I was planning on using. There's a lot of buttons here. You might want to mess around with it. It's not an art class. We just want to have some basic familiarity with it. So that's why I was more concerned with how this data is stored so that we can process that with the script, right? So now we have a long list of numbers, so we can parse through that text file and change those numbers and make that image change. That's the important part. So vector graphics for 2D is SVG format, and 3D, all of our formats are essentially like this. But you'll see what they have in common is a long list of vertexes that get combined into the faces that we want, or the edges and the faces that we want to create that picture. Otherwise, you'll just want to kind of click and play around with it. We'll look in more detail when we're getting closer to ready to animate stuff. I don't feel the need to spend as much time on the 2D graphics as we did on the introducing the 3D graphics. It's straightforward. It's like what we would do on paper. So just grab your pencil and draw some shapes, and then you can customize that shape to whatever you want. So like that, I'll draw another one over here. So not quite a very good one, but I make that yellow. Kind of looks like lightning, except for that little strange edge at the end, but we can still edit all those vertices. What I missed was the point. Oh, so middle click does the panning. So maybe if I grab one of these points and drag it down to a sharp edge. It'll look more like lightning. Nope, not that far. Maybe drag these in. Oh, am I on a Bayesian curve? That's why. Let me just delete that one. Whoops. Let me just delete that. Go to the pencil. Make sure it's set to point by point graphics on the pencil. And then I can draw something like this. There we go. Fill that in with yellow. And all of our objects are independent, so fairly straightforward to do. Maybe move that back. Object. Lower that in the level so it looks like it's coming from behind the cloud, and kind of like you would draw on a piece of paper. So that one's a little more something I expect you would have seen at some point. But you'll still want to click around on it and play around with it. Don't need to spend as much time introducing it, but that's the one I'm going to use in class because of the vector graphics, because then we can go in there and it's not stored as image data like a bitmap, pixel by pixel data. It's actually stored as an equation, so we can have a script modify that equation, and then there's our animation. If we modify that slowly over time, the equation will be in a different spot, so the picture will look different, and we have animations. So that's the two I was going to use, but feel free to use any of them you want. The main thing I wanted to talk about was our vector graphic formats, and hopefully that makes sense. You see how we kind of had the same thing, the same data. It's just on all our vertexes. We had 3 points for the Blender stuff, and all our vertexes here only have 2 points. The third point is taken to be a 0, I guess. But essentially the same formatted data, and then we have a much better way to work with it when we do things like programming, which is what we're doing here. So 8:13, that leaves us what, about 35 minutes. Does anybody have any questions about that? We're going to come back and look at that in a little more detail when we're ready to animate it. So if you're one of the people that installed that, following my recommendation, you might want to just open it up, click around with it. That'd be a good thing to practice for lab time. If you haven't seen vectors before, there's going to be a quiz question on that. So maybe get a practice of adding and multiplying the vectors. Do it component wise, where you draw it as a matrix and add the X components, add the Y components, multiply one of them by 3, and a picture, because that's what I'm going to ask for in the quiz. I'm going to ask you to do it. So obviously it's going to be very simple ones on the quiz. That way you can draw the picture reasonably accurately. But you can probably make up some problems to do that addition and scale it if you feel like you need that practice. And if you make some up to practice and you want to confirm it, you can send those my direction, and I'll be happy to give it a look over and tell you if you got it right, or make any suggestions. But this is a little over half an hour. We covered a couple things that you might want to spend a little bit of time on. This is an active subject. We learn by doing, so I want to make sure there's time to do stuff. So before we split off, does anybody have any questions about the stuff from this evening? Okay, as always, text messages and have you learn messages are the two things that make noise on my phone. I'm going to be sitting here until 8:50, our scheduled time. You can go ahead and end the Zoom call so the video renders down, but I'll be sitting here by my computer ready to jump back on in a split second. You can hop back on a Zoom call if you have any questions. Otherwise, y'all have a great weekend, and I will see you on Monday.